Hello everyone. Thank you very much coming here this presentation. My name is Yu Saito from Japan. Today I would like to talk about the Zstandard in Python 3.14. And I have questions for you. How many of you are already using the Python 3.14? Thank you. And how many of you are also using the Zstandard? No? Okay, thank you very much. If you don't already using the Zstandard and Python 3.14, don't worry. This presentation is especially targeted for the Python beginners. And our goal of this presentation is to understand the basic mechanisms of the Zstandard. And second point is to know the real-world use cases of the Zstandard. And the third point is to able to understand to be able to use your Python code in Zstandard. Before starting the presentations, let me briefly explain myself. My name is Yu Saito from Japan and working solution engineer for Azure. And I have a master degree of bioinformatics. So yeah, nice to meet you. Okay. And this is today's agenda. First, I will start with a brief introduction. And after that, I will explain the comparison like gzip and bz2 and LZMA and explain some trade-offs. After that, I will explain the basics of the Zstandard and what is new in Python 3.14. And then I will show some code examples. And finally, we have time for Q&A and wrap up. This is a part time of talk, introduction. In this part, I will explain the compression fundamentals for every Python developers. Compression is something that we Python developer usually use it, but we don't think deeply about it. So our goal of this part is to cover the compressions basics that every person should know before to listen to the presentation. Let's quickly learn what compression is. Compression means encoding data in fewer bytes by exploiting patterns. For example, repeated characters can be represented in shorter forms. You can see the example. For example, AAAAA, BBB, CC can be represented as 5A, 3B, and 2C. You can see the example. The latter explanation is shorter than the original ones. This is a compression. Then compression can be characterized into the two patterns. One is lossless compressions, and the other one is lossy compressions. The lossless compression is the compression when you encode something and you don't losing your data. This is a lossless compression. So you have when you using it, you can recover the original data. On the other hand, lossy compressions loses your data when you compress some things. So you cannot recover the original data. This is the two patterns of the compressions. In this case, in this presentation, we focus on the Zstandard, and Zstandard uses lossless compressions. So we focus on the lossless compression from this presentation. And we consider the compression methods, and there is three important key indicators. One is compression ratio, and the second is compression speed, and the third point is decompression speed. They are important key indicators to comparing with the other compression algorithms. In this session, Zstandard is the main topic of this presentation. And this standard is closely related to the Python enhancement proposal, PEP 784. This is because PEP 784 is a proposal that Zstandard becomes the standard library of the Python in Python 14. This standard is one of the relatively new compression method algorithms I will introduce you later. Now, let's move to the part 2 of the talk. Before introducing the basic of the Zstandard, I will explain the trade-offs of existing compression algorithms like gzip, bz2, and LZMA. This table summarizes the algorithm trade-offs. Among the many compression algorithms, gzip, bz2, and LZMA are often used in the Python code. zip is widely used in a variety of the situations and have a good speed, but compression ratio is limited. And bz2 and LZMA is a good compression ratio, but speed is slow. On the other hand, Zstandard, Zstd, is a good compression speed and decompression speed with keeping a good compression ratio. Compression speed reaches about 500 megabytes per second. This is 5 times faster than the usually we use gzips. And the compression speed is also 3.5 times faster than the gzip in terms of the decompression speed. Let's compare these algorithms more deeply. This graph shows the compression speed and compression ratio. The horizontal axis means compression speed, and the vertical axis means compression ratio. And the blue line means the standard, and the green line means the libs, which is almost the same as gzip. In this, as you can see the graph, we can see the 2 points of the graph. First point is compression speed and compression ratio has a negative correlations between the compression speed and compression ratio. So if the compression speed becomes higher, the compression ratio would be down. The second one is this standard performance is overall well compared with zlibs. You can see this standard is first and good compression ratio. And this graph also shows the decompression ratio, decompression speed, and this is especially important. In the graph, the blue bar means Zstandard, and the green one is zlib, and the light green one is LZMA. As you can see the graph, Zstandard is much faster than the rest of the two algorithms. From this result, you can see the Zstandard is identical algorithms when you need to read many times. Now, we move to the part 3, Zstandard and Python 3.14. In this part, I will explain the Zstandard basics and what is new in Python 3.14. Zstandard, also called Zstd, is a modern lossless algorithm, compression algorithms. And it was designed to excellent the balance among the compression speed, compression ratio, and the decompression speed. The Zstandard was defined in RFC 88 and 78 and was designed to be a next generation standard on the compression. Next, let's look into the CPython repository on GitHub. Then you can find that this standard was implemented with Python and C languages. First, you will find the compression packages under the lib folder, and under the compression packages, you will find the Zstd module and bz2, gzip, lzma, zlib, and so on. And in terms of the Zstd, you can find the Zstd refers to the underbar Zstd. Underbar Zstd is the core logic implemented by the C languages. So under the C languages, you can find the compressors and decompressors, such a main logic of the Zstandard. This is the overall of the CPython repository architecture. Now you can understand the Zstandard gradually. In this slide, I will briefly explain how Zstandard works. Zstandard works in two phases. One phase, phase one is dictionary matchings, like LZ77, to find the repeated patterns. Here, okay, I will zoom in. Repeated substrings are composed into a tuple of offset and length and next characters. So in this article, the LZ77 output will be 00A, 11C, and 34B. And these standard algorithms and phase two is entropy encoding. Entropy encoding can be done with Huffman encoding and finite state entropy, called FSEs. So let's zoom in. The LZ77 output will be split into the two streams. One is literal stream, and the second one is sequence streams. So literal stream is encoded with Huffman encoding, you know. And the second sequence streams is encoded by the FSEs. So this is overall of the algorithms of the Zstd. So this is the sequence streams and FSEs is characteristics of the Zstd, which is not used in the other compression algorithms like the gzip and bz2 and lzma. So this is overview slide. Next, I will introduce some real-world use cases. This standard is already used in many real systems. For example, Chrome is using the Zstd for the content encoding, and Docker is using for the image layer compressing, and Kafka also using the compressing for the messaging, and Linux kernel for the file systems, and Facebook for the logging systems. So this is not an experimental algorithm, but it is very well proven in production. So far, we can understand the basics of the Zstandard, but how change in Python 3.14? I will explain in this slide. Before 3.14, Python 3.14, each compression method has its own API, so it's slightly different API. But this standard requires the third-party packages, so you need to install the pip install when you want to use it. After Python 3.13, a new compression package namespace was introduced. So all algorithms, including the GSTD, BD2, LZMA, zlib, Zstd, can be used the same from the compression packages, which makes swapping algorithms much easier. Then, when should you use Zstandard, and when should you not use Zstandard? Zstandard is a great choice when you care about latency, like HTTP and API. And when you should use Zstd to read data frequently and handle many small payloads. On the other hand, when should you not using the Zstd is you have to support the very old tools, and max compression ratio is the top concerns. This is the part 4 of the talk, code examples. In this part, I will explain some code examples, and I will explain the API design, classes, and how the Zstd integrated with the gzip and tar files. Before diving into the actual codes, I will introduce the main methods and classes of the Zstandard modules. As you can see the table, they provide several types of the category, one of which is one-shot compression functions and file-based APIs and streaming APIs and directionally training APIs. This unified design makes compression code much easier to write and maintain. Okay, let's move to the actual example codes. This is the simplest way to use Zstandard. You can compress and decompress your data in one shot, which is ideal for in-memory data under megabytes. So you can see only you have to do is to using the compress method or decompress method like this code. The API is very similar to the other compression methods. And the next example, you can read and write ZST files in text mode and binary mode. When will you use text mode, set WT or RT as open parameters, as I show in this slide. And also, when you would like to use binary mode, you have to set RB or WB as a parameter of the open method. This is a very simple way to use. Okay, third examples. For large files or streaming data, you can use Zstd compressors. It allows chunk-based processing, which is useful for networking streaming and large datasets. This standard also supports multi-threading compressions for even higher throughputs. When you want to use multi-threading compressions, you set the compression parameter NB workers as an option, as I show you in this slide. This is a fourth example of this code. This is a dictionary training. Dictionary training is very powerful when you compress the small payloads. By training a dictionary from the sampling data, you can dynamically improve the compression ratio. This is especially useful for the JSON record and API responses. When you want to use in the dictionary trainings, finally, you will use it. When you want to use the dictionary trainings, you have to use the train dictionary method like this, and then get the trained dictionary and pass it to the compress method as a parameter. This also is simple way. And this is the last example of this presentation. And you can create and extract the zip file and the tar file with Zstandard. When you want to create a zip file, set the zip underbar Zstandard as a parameter to the zip file. And when you want to create the tar file, set the parameter as w colon zst. This is the end of the example code. Now, we are close to the end of the session. Before ending the session, I will talk about some conclusions. Listen to this presentation session, you could understand what the Zstandard becomes. Zstandard becomes a standard library for the Python 14. However, in the real world, most systems are still running in the earlier version of the Pythons. The good news is that Zstandard API is almost identical with between the standard library in Python 14 and the third-party libraries, which is installed by the pip. So you can easily migrate the Zstandard code even if you are already using the third-party packages today. You can switch the minimal changes when you upgrade the Python 3.14. This is the last slide of this presentation, and I will summarize today's talk. I explained some of the compression method algorithms in this session. This standard is excellent, especially for the compression speed, and can be used variety of the scenarios like real-time processing, pipelines, and HTTP, and log archive, and data lakes. And LZMA is excellent, especially for the compression ratio. So use LZMA algorithm when you want to maximize the compression ratio. And third, the gzip is widely used in the compression algorithms. So use gzip to keep the legacy compatibility. From the Python 14, compression zstd is part of the Zstandard library, so pip install command is not needed to use the Zstandard. That's the end of the session. Let's use the Zstandard if you don't already using it. Thank you very much for listening.
Thank you once again, Mr. Yu Saito. Now, for anyone who has questions, we are open to a Q&A if you have any questions. Anyone? Yes?
Hello. Thank you so much for your talk. I have one question. Personally, where have you used Zstandard before in your work or maybe in personal projects?
So your question is, before the...
where have you used Zstandard before?
Okay. In my experience, I use the Zstandard to for the logging system to reduce the and optimize the cost to the cloud to the storage services. So this is in my experience.
Okay. Thank you so much.
Thank you. For any other questions, we have time for a few more.
Thank you. And my question is, how efficiency for your experience reducing cost? How long time reduced?
Thank you for your questions. In my personal feelings, about half or 1/3, the logging text will be reduced to half or 1/3. Yeah. So this is a very cost saving for me.
Python 3.4 is a version, right? Version 3.4, right?
3.4, yes.
Okay, so if it is 3.4, like the version is like 3-4 years ago. Right now they're using Python 5, Python 6. How is the Python 5 and 6 working against Python 3.4 in Zstandard?
So, sorry, let me check your questions. When we using the Python 3.5 or 3.6,
As the version grows, the systemic things about the Python structure changes. So the Z standard for 3.4 could not be adapted to Python 5 or 6, right?
Yes.
So what kind of changes do you have to do in order to adapt to Python 5, Python 6?
Thank you for your questions. Yeah, it's true that it depends on, sorry, I don't have a concrete answers for now. Sorry. So, yeah.
All right, so maybe we can talk more about that on Discord if there are any follow-up questions to that. If anyone would like to ask a question, I think we have room for 1 or 2 more questions. Anyone? Yes.
So in ZSTD, like, what's the meaning of Z? Does it stand for something or does it represent something? What is Z?
Sorry, could you repeat more slowly again, please?
So in ZSTD, what is the what does Z mean actually? Does the Z stand for something?
zlib. Okay. Zlib is concretion algorithm which is used, which is similar to the zip. So zlib is slightly different between the Zstandard. Sorry. This is the standard algorithms, and zlib using the encoding the information by 2 phases, but only the left side is conducted. So in short words, this standard is a little bit complex compared with zlibs in terms of the encoding information.